Okay, okay guys, quick video on probability more than anything else, mainly because I saw so many kind of weird and eccentric answers on Friday that I think this just needs to be done. Okay, so we're going to talk about three different things, and the first one is going to be the generic probability that you do at GCSE. So you've got something like a question here, we've got probability of something happening is 0.2, do 300 trials, and you just multiply the numbers. And that's probably what you're most familiar with. And that's what a lot of the things that when I saw on Friday people were doing. The thing is, that's not all. And we're going to see a couple of other things which you may or may not have seen at GCSE. You probably have if you've done tree diagrams, something like this. But it's really important you don't get them confused. Just before we leave this particular example, which as I said, the generic example is not particularly anything special, just remember that that is an estimate. Yeah, that 300 times 0.2 on this example. If you actually did this in real life, you may get 60, you may get 59, you may get anything in the range between 55 and 65 most likely, but there's no guarantees. You may get 2 as well. Yeah, it's not very likely you do. So just be aware that like this is this an estimate. It's not a hard and fast rule, and you can't expect that you're going to get exact numbers every single time. Okay, let's have a look at some of the other things. Okay, now we've got the second type of question, and this is the one that I think people struggled with most on the Friday and on the big A3 sheet. The idea of things being in order and where and when things, whether the order of things matters. So here we've got a question where we've got probability of an event being 0.2, and we're going to do it 3 times. We're going to try it 3 times, and we're going to have, we want the probability of it happening, then failing to happen the second and third time. How do we deal with that situation? Well, we literally just put them in the order. 0.2 is the first one. The chance of something not happening is 1 minus the chance of it happening because they're mutually exclusive. Or you can either have one or the other. You can't have both simultaneously. So you end up with 0.2 times 0.8 times 0.8, which is 0.128. Pretty simple, right? And there's not really much more to that other than it's not 3 times 0. Whatever, 0.2 or 0.08. It's not even 0.2 times 2 lots of 0.8 either. They are multiplied to each other. It's powers, not multiplication. Okay, let's have a look at the third one. Now the third one's probably the most complicated of all. And it's really important that you get a handle on how this works. You've got probability this time, and we want to know the chance it happens once and fails to happen twice, but we don't care about the order, which is different to the previous question where we did care it had to be in happen, fail, fail, or whatever, right? So let's just keep this as simple as we can. We create the sample space, yeah, the sample space diagram. We write down all the things that could happen. Then we pick the 3 or 4 or 5 or 1 or 2 or however many that give us the thing we want to happen. And then we add those probabilities together. You see, I've done a right and a wrong answer. Like the wrong answer was just like people go, oh, and this is something people do quite a lot. It's like, okay, there's three things that I want, and out of 8 things that are happening, so the answer is 3 over 8, which is 0.375. No, that's just wrong. What you need to do is work out each individual probability, FFH, FHF, HFF, and then add them together. Yeah, I've noticed that they're all the same, so I've just done 3 lots of them. Okay, but it is different. As you can see, the answer is different to just doing 3 over 8. Okay, I hope that makes sense when I put this all together. Hopefully you notice new camera, slightly better than before. Okay, have a lovely day. Bye.